Okay, welcome everybody to another career panel discussion with the Northwestern CIERA REU group. This year we have panelist Paula Acioli, who's the professor and chair of the Department of Physics at Northeastern Illinois University. We have Brian Nord, who's an associate scientist at Fermilab, visiting research assistant professor in the Department of Astronomy and Astrophysics, and senior member of the Kavli Institute for Cosmological Physics at the University of Chicago. We have Airy Socrates, who's the director of data science at Juvo, and we have Trouille, who's the vice president of citizen science at the Adler Planetarium and co-lead for Zooniverse. My name is Aaron Geller. I'm the director of the Northwestern CIERA REU program. And I host these career panel discussions every year with our students and also bringing it to other REU programs. This is also will be archived on YouTube, so you'll be able to watch it there later. And I'd like to just get us started with a bit of motivation for why we have this panel discussion. And this is really coming from a longitudinal survey by the American Institute of Physics, people who were in astronomy graduate school in 2006 and 2007. And then following them on for a few years after that. The summary of what they found is that the overwhelming majority of the students did finish their PhDs. More than 3/4 went on to a postdoc. And for those of you who are watching that they don't know what a postdoc is, this is a research position that you can get after having a PhD. There's postdocs in many fields. This in particular, we're talking about astronomy. After that, only about a half remained in academia, roughly 5 years after the PhD. So that's academia is the career path that would get you to be, for instance, a tenure track faculty at some university, teaching and probably also doing research. The other half, or a little more than half, are or were in some federal agency or an observatory, a national lab, or a for-profit or not-for-profit, or in the government. Really ranging a very broad group of different career paths, a broad range of career paths. But regardless of the employment, more than half of the people surveyed say that they do research at their job. Okay, and also regardless of having a postdoc, the overwhelming majority of the people in the survey say that their PhD gave them appropriate background for their current job. But in short, the motivation really is that most, or maybe at least half of the astronomy PhDs don't go on to careers in academia, and they go on to a broad range of other different careers. But the training that they get for their PhD was still very valuable. And it's not always the case that we, as people who are going through grad school, it's not always the case that we know about all the other career paths. And of course, how do we learn about these? Well, one way is through a career panel like this. So that is why we are holding these career panels every year. And hopefully, you all watching get a little bit out of this that maybe shows you some new directions that you could go, or maybe affirms what you had thought and where you want to end up. So let me, at that, hand it over to the panelists so that they can introduce themselves. I'm going to ask them to say a little bit about their path, where they, how they got to the certain career that they are in now, and if they have any advice that they want to give, now is a good time. But we'll keep this brief, and then we'll open it up to questions afterwards. So, Paulo, why don't we start with you?
Okay, my name is Paula Seola, as Aaron said. I'm the department chair and professor of physics at Northeastern Illinois University. This is a 4-year undergraduate institution, not an intensive research institution. And my path to get here was actually very traditional. I went to undergraduate institution in Brazil. After that, I did my PhD in condensed matter physics, computational condensed matter physics at the University of Illinois, Urbana-Champaign. Went back to Brazil, got an academic position, came back to the US on a sabbatical visit to Argonne National Lab. And after that, I came to Northeastern Illinois University. as an assistant professor again, and that evolved, got promoted to professor, and now I am the chair of the physics department. My main advice at this point is really follow your career, make sure you keep close ties to the people that helped you through your career, your faculty mentors, your the head of the labs that you work in, because that will actually be very helpful in opening doors for your career in the future.
Thanks, Paulo. Okay, let's go on to Brian.
Hey, good morning, everyone. My research right now is applying artificial intelligence to astrophysics. This is what I've been spending my time on for the last year-ish, I guess. And what I hope to do in the coming few years with this is show that we can discover new physics by mixing models of what we know with underlying physical laws and what we know from data-driven models from AI. I got here circuitously. So for the last several years, it was my internal ethos that if I couldn't do any kind of community-oriented outreach, then I didn't know how I was going to do physics. And if I couldn't do any physics, then I didn't know how I could do any community-oriented outreach. I wanted to have authenticity kind of going in both directions. So that was true before I knew it rationally. So for the past 10 years, I spent significant fractions of my time on mentorship or in just engaging with the public in various ways. And currently, my position is a new one for Fermilab, where I get paid nominally 50% to do public engagement or community-oriented outreach. So that's what led to this joint appointment at the University of Chicago. And I think I just got there by, in a way, being stubborn, in a way not knowing what wasn't possible. That helped me avoid being constrained by it. A lot of that was luck, and a lot of that was privilege. And so, yeah, so that's what I can think of for the moment in terms of my path. The primary advice that I would give is value your non-career life, value your mental health. I've seen a lot of people, myself included, go through learning environments and mentorship environments that were not good for them. And that's because many of the people who mentor us or attempt to mentor us are not trained or not equipped and do not value that side of the relationship. And it is everyone's onus to find a relationship in terms of mentoring that is right, but the person who is mentoring isn't always going to know that. So if you're an early career scientist, I encourage you to find as many mentors at all times as possible, and filter them. Keep the ones that are pushing you in the direction that you want to go, and that are with you for that ride, that are not just trying to pigeonhole you into what they think you should be.
Thank you, Brian. And okay, Ari, let's move on to you.
Okay, so my name is Airy Socrates. I work at a tech company in San Francisco. I've been formally out of academia for 5 years, but there is actually kind of getting back into a little bit, and I could fill you guys in on that later if you're interested. But yeah, so I work at a company now where I was the 9th employee, and now we're close to 100 after working here for 2.5 years. I'm the head of data science. I figured out how to, hire other data scientists and mentor them, sort of, and felt the growth of a company, which is really a unique experience, and I'm glad I went through it. I mean, my background is I have a PhD in physics. I from UC Santa Barbara. Then I had a fellowship at Princeton University in astrophysical sciences, and then I was a long-term member at the Institute for Advanced Study. The reason why I left theoretical astrophysics was really the way, I had, just to be frank, I had trouble getting a faculty position, in particularly a good faculty position, one that I liked to or wanted to have. And the reason why that was the case, I think, was because the way I went about doing theoretical astrophysics was the way I wanted to do theoretical astrophysics, which was pick a problem and work on it for 2 years or 3 years with a friend, and then pick another problem in a totally different field and work on it with another friend. And that's how I like to do things. And that's how theoretical astrophysics used to be in the 70s and the 80s, but not in the last 15 years. And so that I kind of was a bit of a fish out of water, and so I kind of self-corrected myself out of the field, and and basically there's two paths that were available, and the typical path available when you're exiting academia was to go work at a hedge fund or a bank in New York. And I actually had a couple job offers, but I found out about this field 5 years ago called data science. And, and frankly, I didn't even really know how to program a computer that well, or at all. But I was like, you know what, that sounds really interesting. And it sounds a lot like how I like to work, which is you can pick any company, or like there's thousands of companies here in the Bay Area, and you can pick which one is working on an interesting problem, and if it works out, that's great. If it doesn't, just go work somewhere else. And so at least that's how things are in theory. It's a little bit different, kind of being in a company. And the one thing, I guess the advice I'd have to everybody is there's a lot, when you have a good technical background, there's a lot of opportunities for you out there. There's a lot of really interesting stuff that you could do. I mean, what I'm doing right now is the mission of my company is to create a mechanism for generating credit for mobile phone users in the developing world. That's 3 billion people. That's a pretty good thing to work on. Like stars are interesting, and supermassive black holes are interesting. Extrasolar planets are interesting, but this is pretty interesting too. So the world is sort of your oyster, and just be very positive. There's lots of great stuff to do, and I would say focus on the relationship aspects of things. I think Brian was alluding to that, where the people to people interactions of your work are just important as the non-people to people interactions. And I kind of learned that in the last 5 years, because being in the business environment, you sort of have to learn that if you're going to survive. So that's I guess what I have to say on that issue. So thanks.
Thank you, Airy. Okay, let's move on to Laura.
All right. Hi, everybody. So as Aaron mentioned, or maybe you didn't in the titles, anyways, I am now the Vice President of Citizen Science at the Adler Planetarium. But my trajectory up to date was I was a physics major as an undergrad at Dartmouth College. But even then, I knew that I wanted, as Brian sort of mentioned, I wanted to find some marriage between engaging the public in science and doing science, or at least enabling others to do science. And so my PhD, or even before I went and did my PhD, I took a year off between undergrad and grad school. For me, that was really key. I traveled a little bit in the Czech Republic and then in India, and I taught. But it just gave some time to think a bit more about what I wanted and what I wanted to do. In grad school, I purposefully chose University of Wisconsin-Madison because it's part of this network of the CERTL centers, so Centers for Integration of Research, Teaching, and Learning. I wanted to do my PhD in astronomy, and I studied supermassive black holes and used telescopes. I love telescopes and observing around the world to do that research. But I also chose Madison because of this program where it supported STEM PhDs to take coursework in pedagogy, but also do internships or programs of either education-focused ones or more outreach, engaging the public in science. And so I had this community of other PhD students in other disciplines like biology, chemistry, who had these shared interests. And I know that really helped for me through the 6 years of grad school, really being able to enjoy my astrophysics research and having this community of people who had the dual interests in research and in outreach. I did a postdoc at Northwestern University, but even for that postdoc, from the start, it was set up to be 75% traditional postdoc, do research on active galactic nuclei, and then 25% find different ways to engage the public in science. And part of my advice to people is find advocates and supporters along the way if you have dual interests or a little bit out of the normal model of how to approach things. And Vicky Calagera at Northwestern was one of those people who just really gets why it's so important to find good ways to engage the public in science. And so we set up kind of a special CIERA fellowship just so I could do that kind of two pieces at once. A couple of years into the postdoc, an opening opened up at the Adler Planetarium for a jointly appointed astronomer between the Adler Planetarium and Northwestern. And a few museums and space science institutes and different places have these kind of joint appointments where it's part of the job to both do research and do outreach. And so I was lucky to have that role for a couple of years. And then that turned into, in July 2015, of taking on this role of leading all the citizen science efforts at the Adler. And so it's really 3 years ago that I made a true transition away from doing any of my own research. So I no longer go to telescopes, and I no longer write my own code and analyze data, but instead I get to enable hundreds of others of researchers to do that through the Zooniverse platform. So that's part of the role of the VP for citizen science at the Adler, is to lead the Zooniverse team of web developers for online citizen science. We partner with hundreds of researchers around the world to unlock their data with the public. And then the other part of the role is to lead the Adler teen programs effort. So it's how to engage Chicago's youth, particularly from under-resourced neighborhoods, in all the amazing things that you can do in science. And that's just a whole lot of fun. So main piece of advice is, along the way, kind of echoing what others have said, find those mentors who really understand the full range of what you're interested in. And then whether they're your mentors or others, just find those advocates who can help you create the position that you want, and it may not actually exist. And so how can you create those together and find ways to make clear how it serves that institution's or that person's goals as much as it serves your own, because that really helps to open a lot of doors.
Perfect. Thank you, Laura, and thank you to all of our panelists for the introduction. We're going to open up to questions, and the way that we're going to do it is we will start with the Northwestern group, and we also have, I didn't mention this earlier, but we have the Maria Mitchell Observatory. If you folks want to unmute and say hi, you're welcome to do that. We also have Silvana Delgado Andrade. Hopefully I've pronounced her name correctly. She's joining us, and then we have some people joining us on YouTube, but I'm noticing that our chat feature is not working. So for those of you on YouTube, if you want to ask a question, you can send me an email. Hopefully you have that. And otherwise, you know, we'll be able to take questions, or at least I can help with questions after this. You can send me emails. But without waiting any longer, let's see if our group here at Northwestern have any questions that we can start with. Yeah, go ahead.
Hi, I'm Ethan Marks. I go to Northwestern. This question is for Ari. I was wondering how your physics background translated to your data science career. Like, how easy was that transition? And like, what kind of knowledge did you use from your physics background in your career right now?
Good question. And let me turn off my work Slack. 1 second. Sorry about that. So yeah, so good question. It's a little bit. The answer I'm going to give you is probably not what you're gonna expect. So number one is writing skills. Weirdly enough, like I wrote a lot in physics. I mean, because I wrote papers, and I wasn't that great of a writer when I went into grad school. But you're forced to learn how to write, and so writing skills are really, really important in terms of communication with other types of people in your job. So you do more than just work with engineers and data scientists. You have to work with these people called product managers. I didn't even know what a product manager was when I got into the tech industry. You have to work with marketing people. You have to work with the CEO, and you have to communicate with them effectively. And writing was actually a big part of that. And then I think probably equally the most important thing is that I am using in this capacity is the ability to frame problems quantitatively, and that is sort of probably the most valuable thing that I have in my job is, okay, you see a bunch of data, and first of all, like how do you make any sense out of it? It's like a bunch of weird data that nobody's seen before, especially if you're at a startup or a company that you're starting, and it's sort of like your own universe. Like there's an application and it creates data and it has certain functionality and users are using it, and nobody's done that before. There's never been data like that before. How do you make sense out of it? So you have to be able to be comfortable being uncomfortable and just kind of go into the unknown with the data, and then phrase what you're looking at and why you're looking at it mathematically. And that should be able to map all the way up to the core purpose of the business, including the bottom line. How are you making money, et cetera, et cetera. So that is the real distinction, I think, between the data scientists in my company and everybody else, is that when we look at a problem, yeah, we can think about design, we can think about apps, we can think about marketing, sure, but the way we can think about things quantitatively is really the distinct value added.
Thank you.
Yeah, sure.
Let's see if there's a question from the Maria Mitchell folks. Or Silvana, you can jump into if you have a question.
Hi, everyone. I have a question for Laura. So you mentioned that you went to Madison because of the certain program that they had. Did you look for schools in particular that had these sorts of programs, and how did you go about that?
I think in retrospect, I've revised it to be a lot cleaner than probably reality. So the CIRTL program, the Center for Integration of Research, Teaching, and Learning, what's nice is it's now expanded to, I believe, 40 really great PhD programs that have one of these centers. But a lot of other universities, even if they're not part of that network, you can find, by talking with the grad students, by talking with the faculty, you can find places that really advocate or have interesting programs if you're interested in the outreach and educating the public and science side. Even if they're not part of the CIRTL network, various departments have a commitment to this, and they make it really clear, and it's part of their ethos, and you can tell from the grad students if it's a real thing or if it's just lip service. So part of it is just reaching out to institutions you might be interested in for grad school, for example, and just asking those questions, seeing what programs happen, seeing what you might be able to tap into in terms of an existing thing. I did find it helpful to be that connection to other departments like chemistry and biology, where grad students had similar interests, and sort of having that existing network that I could jump into. So that's why the CIRTL part was nice, but it's not a must-have. It was just helpful. Does that answer your question? Yeah.
I kind of had a follow-up question also, if that's okay. Did you kind of always know that you wanted to go into sort of international outreach, or did that kind of develop as you moved forward in your career?
Thank you. Again, in retrospect, it seems to make sense. My father's French, half my family's French. I've always loved to travel, speak other languages. And astronomy is such a special subject in that, one world, one sky, and there's this amazing opportunity for connecting across countries, sort of international diplomacy through astronomy because of the nature of our science. And it's that case for physics as well, just because of international collaborations. And so I've been drawn to this ability to use an outreach platform like Zooniverse, but there are others where you can connect people from all over the world. Like one of our Zooniverse volunteers was messaging me the other week. He's a high school kid in Hong Kong and came across the Zooniverse, and it just provided him a new window or avenue to connecting with people, but also with science. And he's just some kid across the world. It's fun. On the CERTL thing, just another aspect that was helpful about it, being part of this sort of established program, was it did give a certificate. And so it just provided this formalized or formal recognition of effort in coursework alongside my, the PhD itself. And that did help open some doors in terms of, I know when I was applying for different positions at the Adler Planetarium, the people who were outside of my field but who were reviewing my application could just see those things on my CV, and I know it just helped. So even if you're not part of a formal program, if there's ways, whatever programs or projects you pursue that are not just your PhD, if there are ways to formalize them or have recognition for them or be awarded grants or different awards because of that work, it just helps open doors because it shows up on your CV sort of in black and white.
Thank you. Let's give the folks at the MMA a chance if there's any questions.
Yes?
Yeah, I can hear you now.
Okay, sweet. So Airy mentioned that it was really important for him to find a job that incorporated his method of working. I was wondering what role that played in the rest of you guys getting to be where you guys are right now.
I could try to take a crack at that, I guess. So I was actually just talking to some grad students at UChicago yesterday about this, or the day before. I think there's going to be tension and balance sought at all times in this. I've had to bob and weave quite a bit, anywhere from sort of a small scale thing like I can't work in a cubicle, so I would just go work in an open space area in my building, to I've changed sub-careers so that I could work on answering the questions in the way that I wanted to answer them. So right now I really like trying to take a crack at fundamental issues and how we model things, and then not getting into the weeds of what the astrophysical issues are with that model necessarily, just trying to kind of blow up a subfield. And maybe later I'll come back to asking more fine-grained questions about things. Whoop, whoop, yes. So funny enough, DARPA has a line of funding called disruptioneering. So that's kind of how I feel like what I've enjoyed about my career so far is that I try to disrupt how things work to try to find new angles on it. But for me, I guess the key is the way that you work is probably going to change. So you might know that the way you like to do it now is, if you figured that out, that's great. But as it changes, you want to maybe set yourself up to adapt to a new working environment, or adapt to finding a balance in that working environment with how you work requires you to be a little bit flexible in sort of your attitude and in terms of how you approach people and in terms of how you approach your work. So every 3 months, for example, I think about what I want to do, and if I'm meeting my sort of 3-year, 5-year goals. And if I'm not, then I think about how I need to switch up my daily routine, or how I need to switch up even who I'm working with. So I think in most careers, but I would guess I haven't been in most careers, but in academia and in tech, some flexibility of mind and some flexibility of the way you communicate with people, I think will be really useful.
See if any of our other panelists want to jump in.
Well, I would like to speak a little. I have had different jobs, and I've been happy at different jobs, not knowing exactly what I want to do. After I finished my PhD, I went to an institution that was research intensive and also teaching intensive, so I had that experience. And when I went on my sabbatical, I wanted to experience what would be to work only in research, thinking maybe that's what I wanted to do, because sometimes the teaching, you feel like, okay, maybe that's interfering a little bit in your research. So I was on an extended sabbatical for 2.5 years in which no teaching was involved. And I was really happy to go back into a teaching institution. And I think that a big lesson is that, be flexible. You should be able to adapt. And sometimes you feel like you are set on a career path, and maybe you're not going into that direction knowing exactly what it entails. Because I was really happy going back, because when you teach, when you mentor students, you see really a development of talent that when you are only in research, maybe you lack that part. So I think a little bit of, it's not closed doors, be open-minded about future career paths.
Could I add one more thing?
Please.
So a lot of academicians tend to really overwork and feel like they need to cover all bases at all times. And so I'm a millennial, just to give you a sense of my age. I'm a millennial, but just barely. I was around for the 80s, but I've only just learned recently that the way that I want to approach my work life is that if I don't overwork and I work in an efficient way, and not joining all the committees that I can, for example, then I have this other time during my work life or my work time to like understand other technical things in the world and understand other, say, communication technologies, meaning like the soft skills communication technologies. So I'm still like doing work stuff or work-oriented things, but I'm doing it in maybe a skill set, or maybe in a place that is applicable to many areas of my work time. So you can study other things. You don't. I guess what I'm saying, you don't have to be involved in an official capacity in everything that's going on in your institution. You can take some of that slosh time that you feel like you're not using, and then learn other things that you then will eventually be able to apply in a more efficient way when you're actually on a committee. So especially if you're into social justice, a lot of us really just join way too many committees because we think that's the way we're going to get stuff done. But take a step back and think about what other skills you can acquire sort of in the background through other study that will then serve you in moving from sub-career to sub-career or career to career also.
Thank you. Anyone else want to jump in with a final comment on that question?
Maybe just a note that as an undergrad and as a grad student, you have lots of possibilities for job shadowing or taking that time to do an internship. Like, it's amazing for all of you who are doing REUs to see at a different institution how research works. But if you have those opportunities in the summer, or taking a semester to work at a for-profit company or work at a museum, if you have those interests, take advantage of that flexibility in your time now to be in those institutions and see what the work is truly like, or get to know some people who work there and just job shadow them or do short interviews. Maybe this is a good moment also to mention that on the AAS website, if you go to, or just search AAS, AAS stands for American Astronomical Society for the physics ones, but AAS.org, and go to their careers part, and there's career profiles, and the APS, the American Physics Society, has the similar kind of career profiles, just to see all the different opportunities that are out there. But it really helps to have conversations or job shadow or actually do internships in different places you might be interested.
Thank you. Let's take a question from the Northwestern group, if we have one.
I have a question for Ari. So my name is Mahawat, and I go to Harvard. And my question is, so you mentioned that in the 70s and 80s, like they did theoretical astrophysics differently, where you could just, tackle different problems as you please. So how would you describe the field of astrophysics now?
That's an interesting question. Definitely, when I left the field of astrophysics, I wouldn't describe it in the most rosy picture. But so actually, let me kind of preface that question with a little bit about what's going on with me right now, which is I accepted a position recently at the Department of Astronomy and Astrophysics at UC Santa Cruz as an adjunct professor. Because I sort of kind of wanted to go back into it a little bit, just kind of dip my toe, and because I sort of missed it a little bit, and what really triggered that was it was the discovery of gravitational radiation by LIGO, which was the result of a gigantic collaboration of people doing an almost impossible measurement in discovering probably the most impressive measurement in all of physics, and probably discovering the most, in my point of view, the most amazing astronomical event ever recorded. And so that is the result of a lot of people, a huge amount of people over several decades working on one project with a singular focus. And to me, when I was in theoretical astrophysics, I found that very unappealing. And not only that, but I sort of developed a hostility towards it, because I in my point of view, I thought that what made astrophysics interesting was not any one thing, like stars or black holes or whatever, but getting sort of a cultured sense of the universe and working on different things. But as time went on in the field and people got more specialized, because certain areas of the field got more and more developed, that just became harder and harder to do with the funding, especially with the funding per faculty member going down and down and down as a function of time. So people started to balkanize their work. So I guess the answer to your question with that long prologue was look, I was proven wrong. I mean, the thing with LIGO, if that was some really, really great work, and if I could have been a part of that, I would have been, because it was really great. And my first idea, my first paper was about the merger of black holes and producing gravitational radiation, and I just didn't get interested in that topic because I just never thought that was the way to go about it. But I was totally wrong. And so, and about, like my mode of work, which I kind of said, like, I like to work with a friend, and then for 2 years, that in the tech field or in the business world is called an individual contributor. And so when here in my work life, I'm the head of data science here. So I have to be a manager and a leader, which means that I had to appreciate and grow in certain capacities to be able to do that. So it's not really about me being clever anymore. It's really about me helping guide other people to become clever. And that was a very interesting and rather difficult transition for me to make. And it required a lot of self-awareness that I didn't necessarily have before. So in like academia, and you're worried about getting a job in academia, and you're stressed out about it. Like, look, there's great things inside and outside. There's really great problems to solve in academia, really great problems to solve outside of academia, and don't pin yourself into any one way of thinking. And that was a mistake I made, and just don't make that mistake is sort of my advice.
Thank you. I wonder if, do any of the other astronomers or physicists want to weigh in on how things have changed over the years?
I have one brief comment. So I think right now we're in the midst of an upswing in the utility of what I'm just going to blanketedly call communication technology. This is not hardware. This is how people interact. And this is sort of what Ari was saying about making people around him better. I think that this is a kind of like the dark matter. This is like a hidden skill that will have a huge effect on how groups can be successful, but not everyone is training themselves. Not everyone is applying it. So if you were to develop this skill for yourself right now, then in ways that it's hard to explicitly show because our metrics for our work and the way that we're appreciated either in awards or through our paycheck don't account for it. But you will be really effective as a team member, and you will in many cases become known for that and then become a valuable resource to the community and to the team. And so you can develop skills in communication technology. I think you'll be ahead of the curve. At least right now. I don't know how long it'll take our community to take this on, but I think now is a good opportunity to get in at sort of the ground floor there.
And then on another sort of side of things, just to reiterate some of the points Brian mentioned earlier about sort of mental health and culture and climate, I think that's something that is headed in the right direction in different departments. I know more about astronomy than in physics, but as an undergrad looking at grad schools or as a grad student looking towards where to do a postdoc, just talk with people in those departments and see if it's one of those places that's truly headed, that's just truly headed in the right direction or has the right mindset around those issues around culture and sort of support. If that is something that you see in yourself that will make it a place where you can sort of succeed and grow. But there's enough departments that are making that a priority or a piece that's important that you can find a place that if that's important to you.
Thank you. Anyone else want to weigh in on this question? Okay, let's open it up to either the MMA folks or Silvana. Do you have any questions that you would like to ask?
Hi, can you hear still? My name's Kayla Pittman. I go to Williamsville College, and my question is kind of inspired by Ari's comments, but anyone on the panel can answer it. I'm wondering if you can discuss the current state of interaction between observational and theoretical astrophysicists and how, I guess, they work together to solve common problems.
I mean, I can take a shot at that. Can you guys hear me?
There was an echo for a minute, but
okay, that was a little weird. So yes, I mean, since I used to be actually, I'm a theoretical astrophysicist. So I can tell you a little bit about that. So it used to be very discrete, and the people who made a lot of impact in theoretical astrophysics, in my opinion, weren't just solving the hardest equations and doing, like writing tons of papers with like 500 equations in them or something. The two people that I can think of who historically, at least in the last few generations, who were the most effective from the theoretical side, which I would say probably Bohdan Paczynski and Rashid Sunayev, they worked very close with observers. They didn't necessarily collaborate with observers, but they were talking to them constantly. And this is actually really important, as well as I think an interesting principle for the field I'm in now, which is data science. Is that they were what they really understood is how the instruments worked. And so I feel like that was what was really unique about them, is that they understood every X-ray telescope or gamma ray telescope that went up optical telescope, they would talk closely with the people who built the instruments, who were in charge of the campaigns, about every little nitty detail about those instruments in their surveys. And that allowed them to be a little bit ahead of the curve from everybody else. And so in general, that level of intimacy is what the people who are really successful on the theoretical side do with respect to the observational side. And from I think from the observer's point of view, their interactions with theorists is to, at least nowadays, is to make some of them aware of what they're working on and kind of double check their thinking of why they're undertaking the campaigns that they're undertaking. So it's a very, very symbiotic relationship. And at least historically, the people who could work very closely were the most successful. I think in data science, the understanding the instrument is really important. So if you can, as a data scientist, get some pretty good engineering skills before you go into the field and really understand where the events from your production system, where the events from your application, where the data that you're ingesting from a third-party source, how that really got there, how those events were generated, you're going to be a lot better at your job, kind of going through that extra few miles of the engineering work, because you're going to understand the instrument better. And if you can understand the instrument better, you're going to be a little bit ahead of the curve. So, thanks.
Any of our other panelists want to jump in on this? Okay, I want to take an opportunity to ask I guess kind of a basic question, and this is for all the panelists. Can you describe a typical day at work? And let's go again in alphabetical order. So let's start with Paulo, if that's okay.
Okay. Currently, as department chair, my current day at work is to talk to students, sometimes solve issues regarding grading, maybe complaints, try to run the day-to-day activity, making sure that all classes are running well, that we have enough faculty to teach all the classes. So this is the boring part. Part of it as well is preparing classes. I teach one class a semester. And that's basically it, right? So just running the bureaucracy, making sure that hopefully I'm not seeing a lot so that things work smoothly and students don't have many complaints and faculty can do their work well.
Thank you. Okay, let's go to Brian.
Is there such thing as a typical day? Every day is a new adventure. So I have an ideal day, and then I have how that ideal day gets descoped. So ideal day, I'm an early morning person, much to the chagrin of many people around me. I like to get up by 4:30 or 5 into the office by 6 after being at the gym, at least for a little bit. And then I try to do a lot of planning of my day. So I like to think out how, and nominally that would be done the day before, but so I'll do a little bit of planning about how I want my day to go in terms of getting work done and who I'll talk to. Hopefully I'll only have a few meetings in a day, and hopefully those meetings will be more about getting things done than about just hacking around, hashing up issues. And that unfortunately tends to happen a lot in academia, is that people just say, hey, we're gonna have an hour meeting, and then you fill that hour like it's a glass of water. That's not my perspective. I wanna get things done. So during the day, I'm often talking to early career scientists about what their research is and trying to help them move the needle on that. And then I have a lot of my own personal hack time to get some research done. So I'm mostly coding and writing on my whiteboard. I don't know if you can see it around me. If every surface were a whiteboard for me, that would be great. That's kind of how I think. And then, yeah, a few meetings I do. There is bureaucracy. I will never get away from bureaucracy. So I get through it, and I make it as efficient as possible. And then I try to get out as early as possible in the day. So I like to, if I can get home by 3 or 4, that's great since I've been in early.
Thank you. Airy will be right back, but let's go to Laura.
Yeah, similarly, no day is the same, and I like that very much. It's part of the appeal for this job. So a random choice, I was looking at my calendar. So morning starts with a meeting with my web development team for the Zooniverse, and we do like a half-hour stand-up, just talking about the past week and the week to come in terms of different projects we're all working on across the online citizen science platform. Then I'll have a call with a new research team who have this million image camera trap project where they need all their images tagged with zebras and wildebeest. And so I help them with a project builder tool and think about how they're going to use the data and different resources they can access. Then part of my role is within the executive team or the leadership team within the Adler Planetarium within the museum, and we're going through this master planning process for how our exhibit spaces should better reflect just our transient universe and how much we're learning in astronomy, and just make it a more modern interactive museum. And so we have a brainstorm meeting for an hour as a group of key people who are thinking about what those future exhibit spaces should look like. And then I try to block meetings in time so that I can then have ideally a stretch of 2 hours where I do my own kind of work. And so it's being very deliberate about how you schedule your meetings to allow those longer stretches of time if possible. And then the last hour of the day is planning with some folks about an upcoming conference and some panel discussions we want to put together with different other citizen science platforms. So it's a mix, and definitely all those soft skills, as well as the research, data analysis, problem solving skills that came up throughout grad school, are helping at each of those different moments in the day.
Thank you. Okay, let's go to Airy. Can you tell us about a typical day at your work?
Sure. So in a tech company, it's the how would I say it? The kind of social network structure of a tech company is much different than an academic department. Where an academic department, you have the chairman. Under the chairman, there's professors. Under the professors, there's a research group, and that's just sort of how it is in all departments for the most part. In a tech company, there's the CEO who's the boss. Actually, above the CEO, there's the board of directors, and then under that is a group of managers who sort of run the company that have different functions. And I'm one of those group of managers that run the company that have those different functions. So you have to kind of regularly interact with people, the level above you, the people at your level, and then the people who work for you, who are on your team. And so I'm in a lot of, it turns out like I'm in a lot of meetings. So I have, for the people on my team, I have 6 people on my team, data scientists and data engineers. Once a week, I have a one-on-one with them. So that is an interesting concept that doesn't necessarily pop up in academia, the concept of the one-on-one, where you and your boss basically have a one-on-one discussion every week at the same time about anything. It could be about work, it could be about family, it could be about anything that's bothering the person who the one-on-one is for. So that alone, if you have 6 of those, that takes there's a lot of time there. You got to prepare for them to make sure what's going on with that person's work. So a lot of time I'm kind of just like looking at people's code that they're pushing and the documents that they're writing. I spend a lot of time writing documents. I spend a lot of time going to meetings, talking to our salespeople, talking to our marketing people, talking to our product people, helping our engineers try to better understand like how things should get architected. you know, like I travel a lot too, you know, because we're an international business. We're trying to create a mechanism for generating credit for 3 billion people in the developing world. So how we are actually going about that is using mobile network operators as sort of the base infrastructure for doing that. So we have to make deals with like big mobile network operators in like Brazil and Chile and Indonesia. So I often have to travel there and help negotiate stuff, you know, so it's you know, it's a mishmash between, you know, from what I used to do when I first got here, when I was the first data scientist, which is like building a platform, writing code, like doing math, you know, making plots, to now I'm kind of helping, you know, like advise, you know, people on my team do that type of stuff. And the challenge for me is to actually understand what's going on technically with my team, and as well as like produce a vision for the team, and then map that to the other business needs while spending a lot of time with my peer group, the head of product, the head of marketing, the head of engineering, the head of customer success. There's something called customer success. So the head of customer success, like all these teams, you gotta spend a lot of time with, and you gotta learn to respect and collaborate with. And that's what I basically do. I'm sort of just like, I've sort of become like connective tissue rather than the muscle itself. So that's what I spend a lot of my time doing, being connective tissue.
Thank you. Let me open it up to the Northwestern people again.
Hi, my name is Samantha Berry. I go to community colleges of Chicago. Can you think of an aha moment that like solidified your career choice and like really assured you that you were doing the right thing for you? Just like a little snippet, a good memory that you have.
Did I hear, can I think of an aha moment that solidified my choices? What?
Your career choice.
Yeah, career choice. It's a tough one to pinpoint, I guess.
I think, oh, no, go ahead.
Oh, no, you go ahead. You go ahead.
So it's not so much an aha moment before, but I know that what has been reassuring is, especially 3 years ago when I transitioned into this very new role, the fact that I look forward to work and the people I'm working with, and I'm just enjoying it so much, has been more of a retrospective, like, yeah, this is right. I will say that through the years of being a postdoc, I don't know if the other panelists have had this experience, but I know I've spoken with others who there's a lot of value system and judgments that you sort of start ingraining during grad school. And even Madison was a wonderfully supportive place and very open about the career trajectories, but there was still quite a bit of academia was the correct path forward, and the most highly valued path forward. And so throughout, as a postdoc, I knew that this was likely where I would be. I think deep down internally, I knew this type of role was where I would be happiest, that would feel the best use of my skills and abilities and how I wanted to serve sort of myself in the world. But there was very much years of struggling through accepting that and sort of backing out and figuring out what I truly valued and what I felt was going to be impactful and helpful and best for me versus what I'd sort of learned or taken on or just taken in through osmosis over the years. And so so I think if I had sort of let go of some of that earlier, maybe during those postdoc years, I would have had more of an aha moment of like, yeah, this is it. Let's dive in full force. Instead, it was, let me keep opening as many doors as possible and keep working through how I feel about this. And then now more in a retrospective way of knowing that this is what feels right to me.
So I did not have the aha moment in terms of choosing a career because it was a little bit more natural. You know, both my father and mother were academicians, so it kind of felt like, you know, I was on the right path. I went to undergrad, went to grad school, did a short postdoc, got a academic position. But what I would say that is the thing that I know I'm the right place is that from time to time you get out of nowhere somebody that you haven't heard, a student that can be a major, can be a non-major, that comes and writes back and say, you know, this is what I accomplished. These are the things that I got done, and without the help of the department, the colleagues, we would not be able to get there. So that is really very satisfying in being in academic position, because that's where you feel like you make a difference.
So I had a number of moments that helped me get to rarely punctuated aha moments. The first aha moment I had was in high school when I realized that I thought physics was going to be a big part of my life. I incorrectly thought that physics was going to be a place without politics because you were just thinking about the foundational aspects of the universe, you know, truth. So done. Don't have to argue about it. So that was an aha that ended up in retrospect being like, no, that's not that. So there's a lot of politics in physics. But then similar to what Laura was saying about during postdoc years and some grad, it was like, nah, this way this is working exactly isn't really for me. But I think the takeaway there is check in with yourself frequently to see how you're feeling about things. And in a lot of cases, you got to trust your gut. Like, people are going to tell you, this is just how the system works, and this is how we've been doing it for a long time. If you don't feel happy after checking in with colleagues and friends or checking with different mentors, then trust that, use that until you do find some of those at least small aha moments that are, oh, like I enjoy this because I enjoy the problem or because I enjoy who I'm working with. And all of those are valid considerations. If you're spending this much time, hours, tens of hours per week, like not in the other space of your life that is, you know, not only your home life or your family or whatever that is, if you're spending that much time in this environment, those people, like, why not do what you can to be happy or to not be frustrated? So I had an aha moment this weekend. So we just finished our big event for the public engagement side of my career, which is this thing called Space Explorers U Chicago, where 30 students come in for a week. And I had the aha moment of, one, they re-inspired me to think about why I do science, and also like maybe someday why I want to try to travel into space. But they gave me, it was an aha moment in terms of, I have, at least for this moment, I found something that fit with my aspirations and with what I like to do daily, that I get to think about weird, complex stuff and then somehow communicate it and inspire a little bit other people to maybe think about those things too. So wasn't expecting it, but I got chills down my spine when I was talking to the students a little bit. And that's an aha moment that I'm going to also, that's a moment that I'm going to try to hold on to for when those moments come along, and I can say, oh, where is my compass really directing me?
Airy, did you want to answer this one too?
Yeah, well, when I was in college, I sort of decided to study physics midway through college, and I went totally berserk after. I don't know what it. I always felt physics was really beautiful. It was a very beautiful topic. But you know, like it's hard to know what you're tricking yourself into believing, right? So I'm a data scientist now, you know, and you know, like I'm working on some pretty interesting problems, and I'm pretty into it, you know, like I'll admit it, I'm pretty into it, and it's not physics. And then the question is, well, if I had a slightly different life history or something like that, you know, my parents come from villages in India, right? And so, you know, when I go back to the village in India, you know, like the neighbors from where my dad grew up, you know, I could have been one of the, you know, I could have been a farmer right now. Is not with just a little bit change, and probably I would be happy at it. So I think there's a lot of different, I mean, when you're in these career panel discussions, that means like you have a lot of opportunity and there's lots of awesome things you could do. I mean, you know, like you could be a lawyer, you could be a doctor, you could be a business person, you could be a scientist. You know, like some people, you know, and I don't think I fall into that category. There are some people where there are certain vocations that are really good fits for their personality, and they might not be as happy if they weren't in a vocation like that or something similar to that. But there's many other people could be, I think, happy in different lines of work, and it's really the approach to work and how you go about the work. And you know, Laura brought up this notion of culture, work culture, and in academia, at least when I was in academia, at the Institute for Advanced Study, nobody talked about that. Trust me. And you know, like when now I understand that what differentiates good, like companies that actually succeed and companies that don't succeed is basically culture. Does everybody like each other, work together as a team? And as a team, you can do, you know, you can do amazing things because the rest of society isn't working as a team. so that's a big a big thing to think about. That wherever you go, is it is it going to be emotionally enriched and spiritually enriching for you to be there? And that's not necessarily a function of what you're doing in terms of the actual profession, but who you're working with and how you go about working with it. So yeah, I don't know if that answers the question, but sort of.
Thank you very much.
Thank you.
A quick little comment. If you stop doing if you stop doing academia, this is not a failure. I want to be very clear about this. It is, so in the worst case scenario, if we were to commodify each other, this is a win for your community because you are a technically savvy, critical thinking person who's going to go into a non-tech field and be a citizen who is going to then vote with those skills in mind. But not commodifying each other. Do what you need to do to have a good life.
Thank you. Let's see. Oh, let's see if we can take another question from the Maria Mitchell folks or Silvana.
Yes. No, go on. Okay. This is for Paulo. You were talking about your day-to-day activities, and I was wondering how much you actually get to do research and how that's impacted your decision to be there and to stay in this field, and if you could do more of it if you could.
I still keep an active scholarship agenda. The position is not very helpful as department chair. A lot of your time is spent in some meetings that are not very productive. But for my own sanity, I keep an active scholarship agenda. A lot of that through collaborations, meaning that you divide the work so you can accomplish something. I have students that I work every summer with me in doing some to help me along those. But as a mostly undergraduate institution, I think about a lot there more in terms of training than in terms of actually having papers out. Occasionally, some of them do happen. This institution, when I got elected as department chair, I have very good support from my dean, and she said, take at least one day off in which you don't have to show up in the department, close your door, make a sign, this is your scholarship day. So if you need to go to Oregon, where I have a collaborator, you can be there. If you need to work here in school, get your computational lab going. So I do keep that, but it's a lot of extra work, but it's enjoyable.
Thank you. So I'm just watching the time. I think maybe let's try to take one more question from the Northwestern group if we have it, and then I want to leave just a little bit of time for the panelists if they had any closing thoughts or things that they wanted to say. But first, let's take one last question.
Hi, I'm Jack. We've talked a little bit about how this field and its subfields have changed in the last 20 or 30 years. I'm wondering if any of you foresee any big changes in either the jobs that are available or the way any of your jobs will be done in the next 10 years, because most of us will be entering the workforce in maybe 10 years after PhD and postdoc. So I was wondering if you had any thoughts on that.
I could volunteer something really quick. Well, I see two trends that are really happening that are kind of not really related. The first trend is look east. There's a lot of stuff. If you're interested in the technology sector, there is a lot of stuff happening and wealth being generated in Asia. And that's not Japan. It's like Japan and China and Indonesia and Singapore and Malaysia and Vietnam and Philippines. I mean, Taiwan. I mean, there is a lot of stuff going on over there. And there's one really interesting way, what I just kind of realized recently, way to kind of summarize why it's so much the case right now. A plane ticket, you go to like Kayak or Expedia, go any day of the year, week, or whatever. A plane ticket from San Francisco to Hong Kong is cheaper than a plane ticket from San Francisco to New York. so that's how much traffic is going in that direction. And so there's just pay attention, like the technology industry, worldwide industry and entrepreneurship. It's just not the United States anymore. The East is really starting to come up and to dominate, in my opinion. And the second thing is, if you're interested in the technology field, like not just look at, like, understand like, oh, you know, I have a PhD or a master's and I can do big data science. Like, think of the field of big data as a general field and how you can make an impact on it, not only as a data scientist, but maybe as an entrepreneur or an engineer. And that, I think that will help you spot some trends.
I can jump in next. So speaking from the museum side, but also we don't have any panelists representing sort of government policy type positions. We all are well aware of the sort of state of our union and just the importance of science communication roles, and in the museum, thankfully there's a change in terms of the role that museums play in society today. And so for any undergrads, grad students interested or wanting to have an impact in terms of engaging the public in science, it's an exciting time to think about museums as partners, whether you go full, you continue in academia, but thinking about the types of broader impact opportunities you might have. Look locally in terms of the museums that are around and how you might take advantage of our museum's growing role in terms of how to engage the public in science, how to talk about science with the public, how to even just bring in critical thinking and problem-solving skills through programming and activities through museums with the public. On the government side, there's a growing number of sort of policy and science advocacy type roles. And so if along your career route, you see those as opportunities or places of interest, both the AAS and the APS and all our different professional societies provide fellowship pathways into those types of careers as well, just because we see how important it is for people to be able to bridge that gap and speak or translate between the research world and the public or government or voting, all those things.
I can combine my response with my final comment. So I think, so two things I would say. Even if you're a yellow or legal pad theorist, you will be much better served if you can write code. Code is ubiquitous. If you can't write code, even if you're a theorist who just does equations, I think you're going to be behind the curve if you're not coding, at least for being able to communicate some results. So that's one thing, code everywhere. Second thing is teams. So if you look at the history of particle physics, they went from in experimentalist, they went from small individual groups to small groups, and now they're at thousands of persons per collaboration. And that is at least where optical astronomy is. That's where radio astronomy is. There are still small things, small experiments being done, but look at LSST. That's the name of the game for optical astronomy in the Southern Hemisphere for the next decade and a half. So working in teams will be really important. And then third, something that kind of bridges this to what my final comment is, if you want to predict the future, sort of what Ari was saying, pay attention to global trends in terms of technology, in terms of politics. So China and Russia and US and other places are going to be huge when it comes to AI, because it has to do with what they care about geopolitically. And if you can monitor what those governments are doing, you'll also be able to monitor where the funding is going to come from, and thus what open avenues of research will be.
And Paula, did you want to weigh in at all about changes that you see coming up? And if not, we can go to any final comment. So let's see if any of our other panelists want to have a final comment. I know we're just at the time limit, so I want to be respectful of everyone's time, but does anyone want to add a final comment of the panelists?
Well, I'll just say good luck, everybody, and there's a lot of great stuff out there, and there's a lot of things to be positive about.
Just one quick comment is try to work in a field that you really enjoy, because to be successful, one thing in common is always hard work. But if you're working on something that you really enjoy, it doesn't seem that hard. So you spend many hours doing things that you like. So that, I think, keep an open mind. And I like what Brian said. If you choose a different career path, is not a failure. Make sure that that is really something that you keep in mind, that there are many paths, and always think about other options as well.
And just to re-emphasize, take advantage of all the resources that are now available around careers and career trajectories. And then also just take care of yourselves, your mental health, your happiness levels, because it's not a sprint. It is a long-term, your whole life ahead of you type of trajectory. And so you'll be able to have your focus and energy when your foundation, yourself, you're solid there. And then again, find those mentors and advocates so that when you do have a good sense of what you want to do and where you want to head, and if that particular role or job doesn't seem to exist, see if you can find people or groups, organizations, companies that can help you create it with you. So find your advocates and mentors.
Okay, thank you. I think this is going to wrap up our panel discussion for today. Thank you to the panelists and to everyone else joining us. And thanks for watching the career panel discussion hosted by Northwestern's CIERA Center for Astrophysics. Hope to see you all next year. Bye.
Thank you.
Goodbye.